decided to make this video now, and I was going to put it off till morning, 2:30 at night. Anyway, but I said, nah, I'm just not going to ever be in the mood. But anyway, it's a Ken Wheeler video, so, it'll just be a walk through a bunch of strangled language and lament. I mean, I just can't understand how people can suck this stuff up. Like this is some rational alternative to the, what I would consider a little bit silly. Einstein's a little bit silly. This guy's, completely silly. And it's like people don't like Einstein because it's too rational, it seems, not because it's too irrational. And they want something even more irrational, and especially layered in a bunch of idiotic language. I mean, completely unnecessary verbiage. I mean, just using all the wrong words for things. Anyway, so I'm going to play some of it, and it's, we'll just see how far we get. I only got a minute and a half into it, and I just, this is just, how does he get away with this? How does he get away with it? It just amazes me that somebody can talk this much shit and get away with it. No accountability. Anyway.
Watching me for photography stuff, I've completely forgotten that I've made countless hundreds of videos on field theory.
You haven't done anything about anything real. So whatever your videos are on field theory, who knows what the theory is? The posterior inverse hyperboloid thingy.
And that I've written books and articles on field theory.
Who cares? I read your book. It's incomprehensible gibberish.
And actually I'm an expert on field theory.
No. Expert by whose opinion? I mean, anybody can call themselves, okay, I've decided to create a new thing called conceptual engineering. And yes, I'm going to give myself a doctorate in it. And so I'm a doctor of conceptual engineering.
You actually have to go to the original field theorists like Faraday, Steinmetz, Heaviside.
He's just talking about the original etherists, okay? So it has nothing to do with fields. It just has to do with some idea of some underlying whatever, jello, whatever you want to call it. We're not only in an atmosphere here on Earth, okay? And then they're out in space. It's not bent space or space-time. It's some sort of jello ether. Allergic to the cat. Anyway, continuing.
Nikola Tesla, to get to the heart of it. Everything now.
Yeah, Tesla had nothing to offer except critiques of other people's wacky. But his shit was just as wacky. Remember, this is the guy who spent his life trying to make the death ray. The supersonic electric lightning bolt shooter. You think there'll be one of those?
Has been superseded by quantum insanity, which is based in specifically atomism.
So by atomism he means the fact that they've recognized that there's stuff and non-stuff, kind of an idea. Particles.
Reification of space as something that acts upon other things was called an insanity.
Right, so because they used the word space-time and they didn't use the word bendius, warpo, or some other, give it some kind of, maybe some kind of ether name even, gravether or something. So this is just semantics. He's complaining because their ether theory isn't called an ether theory. Right? I mean, Einstein obviously didn't think space was nothing, and he didn't think time was nothing. So he obviously thought there was something that was getting bent. So, it's just semantics.
A harebrained scheme, as said by Nikola Tesla.
Right, and the coaxial cable connecting me to the sun isn't a harebrained scheme. The photons are little coaxial cables shooting through the jello, the eternal jello. That's not harebrained.
Reference to Einstein. The reification of space is no different than the reification of a shadow.
Right, the reification, again, so I guess this is something to do with like making something real. And so we're supposed to not be capable of understanding that the absence of something, okay, isn't something we can recognize. No, Einstein didn't argue a shadow was more energetic. He didn't argue that shadows were something. He certainly argued that they were an absence of something. But, you know, space is neither. It can't be affected by anything because it's nothing. You can't cast a shadow on empty space, can you? No, you can't.
A shadow is a privation, i.e. a privation of light. We cannot say that a privation acts upon other things, while we can...
Again, a privation of what? And in a Jello world, how can you even have such a thing? The anti-Jello? So there's some sort of, the Jello has some sort of character to it, where it goes coaxial somehow. But there's no details to how this Jello works.
Reify the notion or the premise that sitting in a shadow will cause you to get cold. This does not mean that a shadow is a principle. It's a posterior attribute.
Right, a posterior attribute. Like, you know, your whole conversation is posteriored. Your head's up your posterior. This language, calling something a posterior attribute. Like you could say it's a byproduct, which obviously it is. Something gets blocked, that's a consequence. But what's the point of this posterior attribute when you just said it's not even a rarefiable thing? Something you can't rarefy shouldn't be able to have attributes.
Actually a privation. Space is certainly no different. The reification of gravity as an autonomous field modality. Autonomous
field modality. Now why do you have to call it that? An autonomous field modality. So he knows that Einstein is calling it a field of some kind, a mechanism, an ether. And again, he's arguing with the ether theory, which is his own theory.
Specifically, which is what this video is about, is absolutely impossible based upon everything we know, and most people don't look into.
Yeah, like everything we know says it isn't possible that there's fields when everything people believe in is fields, and certainly everything you believe in is some sort of field of Jello where you can hook cables up to at any point you want to and coaxial your way somewhere.
To the greats of electrical field theory, i.e.
Oh, drop the names again. Blah, 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 blah.
Steinmetz, Oliver Heaviside, Nikola Tesla.
Yeah, ether nuts. You should throw Maxwell in there.
These are the people that gave us 100% of our electrical grid today. And
that's just a silly statement. Just preposterous, insane, crazy. You know, like this wasn't going to get invented anyway. You know, like we weren't going to figure out positive and negative. Benjamin Franklin did it, really. You know, give him the credit. Even though he put the wrong place, he had the plus and the minus in the wrong spots. He's the one who figured it out. Plus and minus.
99% of our understanding of field theory. However, none of these people actually explained what gravity was.
And either have you. Not even close. Nothing. I can't draw a picture of anything you've described as being anything like anything that's cognizable, that you can actually put in your brain and say, okay, I sort of get it. I can sort of get Einstein. Einstein's theory is silly, okay? Yeah, I mean, there's some sort of medium and material things somehow create a perpetual vacuum, okay, when they're in the medium, because, you know, in 3 dimensions you can't do that bent space thing. You have to do the convergence thing, the pulling in thing. So somehow it sucks the Jello, and if anything else is out in the Jello, it gets pulled in because, you know, the mass is sucking Jello.
Force, usually always described as a force. Yeah, once in a while you'll actually find an intelligent person that says that gravity is not a force, it's merely an acceleration, but
merely an acceleration. So again, it's not a force, it's just merely an acceleration that poofs out of nowhere. The something moves for no reason. At least Einstein has some reason. The space, the jello is being sucked. At least there's something. But acceleration for no reason. No, that doesn't work either, silly person.
The four Maxwellian field equations never define what a field is.
It's not their job, but again, they certainly describe pretty well the fact of what's necessary, what the basic components are of the interaction. But they're not gravity equations anyway. I thought this was the subject of gravity this time. Maxwell's equations are about charge.
A field, there's only one field ultimately, and that is a divergent field.
All right, a divergent field. So now at least we have there's only one field. You heard him say it, so that's all we got to know. It's divergent field. So DF. I'll write that down. There's the divergent field. Okay, whatever that means. It does this and does that. We're done now, right? That's physics.
And that would be a Cartesian field, but we can only define a field. And we've never defined a field. Science never has, anyway. I have in my book.
No. It didn't happen. There's nothing in his book defined. It's just like these videos. It's just strangled language on top of strangled language, Steinmetz, Faraday, blah, 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 blah. That's all it is. Name droppies and strangled language.
Right now into the 4th edition, all field modalities, i.e. The four Maxwellian field equations, define a field over a period of time with a given vector.
Yes, we've heard all this too. The impact of anything is going to be over time, right? It takes time. Even a cannonball, if I shot a cannonball straight up in the air and it came down in whatever, Kentucky, and land on your head, it's going to deform your head and it's going to be a time equation. It's going to take, even though it's going to happen in milliseconds of time, little tiny bits of time, everything takes time. So there's nothing surprising that mathematical equations regarding physical events created by Maxwell would be time equations. Yes, that's how it works. Everything's time sensitive. I think you should write that down. Okay, if you don't already know that, everything is time sensitive.
With a resultant effect, but that doesn't define a field.
Again, he wasn't claiming to define a field. He believed in ether. He was a silly ether person. He wasn't defining fields. He was just describing effects. He wasn't telling you why it does this. Again, it's the whole Newton thing. He wasn't telling you how it happens. He was telling you what will happen.
If we can only define Bob by what Bob does or how he affects things or how far he travels, that doesn't define what Bob is.
Oh, well, it's a hell of a definition, frankly. Okay, who, what, where. Yeah, so you got his name, you know where he is, you know what he's up to. That's a lot.
To the notion that gravity is an autonomous field modality is it.
Okay, so again, we're autonomous field modality. And what do you think it is? You think it is connected somehow to your ether mush in some way or another. The jello is somehow what was it? I already forgot what DF stands for. The diffraction field or something?
As insane as a stupid little ignorant child that thinks that water is one thing, steam is another thing.
And more of his pointless metaphoring. I mean, shit. He can't describe his own thing except to compare it to things that have absolutely nothing to do with it. I mean, nothing.
And ice is another thing. And of course we know all of these are just different modalities of water, of the hydrous oxide molecule, correct? So, what about gravity?
Hydrous oxide. Who the hell calls it that? Oh, that's right, nobody.
But, by the way, I'd have you reference a odd little paper you can actually find it free for download. It's called A Gravitational Electromagnetic Analogy by Oliver Heaviside, written in the early part of this century, often quoted by the now late...
No, it wasn't this century, right? It was actually written in the early part of the last century. You didn't write it in 2000, so you didn't even quite get that one right. It's over 100 years old, maybe 100 years old. Ooh.
Oleg Djefimenko, who references it for an entire huge book. He actually denied himself, and he has 2 PhDs. Not that that's important at all, Dr. Oleg.
Yeah, then why'd you bring it up? Oh yeah, because it's all part of this narrative that has no details in it. Just accept my authority. I read Dr. Wacky Who's book, so I know everything about everything.
Djefimenko, in his book on habits called Causality, Electromagnetic Induction, and Gravitation. He also has another book.
Right, and you can't you can't provide a single experiment or evidence for this magnetic electrical gravity thing. You're not going to be able to find it. You're not going to be able to measure any of it. You're just making it up. You're saying that there's some other magnetism that we can't really detect, that's really strong, and it's somehow pulling things together with a magical thing. So that's the description. So that's what people want, as a description of reality. It just magically happens. The thing is there, and the thing's over there, and they just magically attract. Because he's not going to explain to you how they do that. How the bits inside of the thing do that.
On this subject called gravitation and co-gravitation, specifically that gravity is electromagnetic by its very nature. There is no autonomous field modality that we...
Right, it's magnetic, and there's no autonomous field modality. So again, not saying anything, saying saying it's magnetic but we can't measure it with a magnet. So yeah, it's some other kind of magnetic. It's some kind of magnetic we can't detect. So it's unmagnetic or something, or anti-magnetism, or supermagnetism, or some sort of jello magnetism.
That was gravity. Gravity, of course, is not a force. There's only 2 principles.
Yes, okay. Gravity is not a force, except it behaves in every way like one, in the sense that it makes material things move. So, but yes, let's not consider the idea that it's a force, that it's actually something, and the something is moving the something. No, let's just forget about that. Let's just make another magic story. So Einstein has a magic story of the magic force, the magic bent thingy, and you have your magic magnetic jello. And these are the kind of explanations people go for. But some kind of rational explanation like, no, there's this particles in the universe, these little bits. And the little bits are banging into everything all the time, creating pressure, these little invisible photons. And they're absorbed, and their momentum is transferred to the thing they're absorbed by, and that's what causes things to move, is the absorption of energy. Little quanta bits of energy. Oh, that's silly. That couldn't possibly be the answer.
The nature, force and motion, inertia and acceleration.
Oh, that one again. Inertia, force, blah, blah. Yeah, sorry, lost it. Never can remember the lyrics to that song.
We have centrifugal divergence.
Oh, there we go. Now we got to the centrifugal thing. Like that explains it all. Typhoon. Let's compare everything to like a tornado. Left-handed one or a right-handed tornado. Yeah, that's the universe, is tornadoes. Shit.
We have centripetal convergence. Everything is governed by capacitance, resistance, permeability.
Okay, there we go. Capacitance, resistance, permeability, something else. Again, and all this means what? So the jello's permeable. That means things can move through the jello, or the jello moves them. The jello's got like little flagellums that push things along. Something like that.
And permittivity. There is no force involved if you...
Right, so there's just nothing bangs into something and makes it move. So even though we see that all over the place, I can just bang something into something and it moves. Okay, that wasn't really... This didn't get force from me, and it didn't go into the other thing that moved. None of that happened. It was permeability in the jello.
Were, say, at a known distance from the surface of the Earth to let go of something, no forces involved in that object being let go, that it would accelerate towards the Earth.
Alright, so he's saying there's no force to gravity. Again, so he sort of believes, again, it's another Einstein theory. You don't need an actual mechanism. You don't need an actual source for the energy. So like magnetism and the rest of these things, there's nothing there, as much as it looks like it, as much as if like Maxwell, if you imagine a virtual photon, it behaves exactly like that. The inverse square law is dictating how this light bulb works in terms of its radiation, and the same laws apply to gravitational bodies. The same law, that makes my hand get disproportionately larger and smaller, okay, the 4 times the distance, twice the distance, 4 times less size. The same kind of diminishing, the same kind of mechanism as the photons coming off this hand.
Of course, resultantly, however, quite minuscule, the Earth would also accelerate towards that object. They're mutually accelerant, but obviously the Earth is not going to move in response to, say, a 5-pound bowling ball, for example. But gravity is not...
Well, see, the trick is, though, is that it is. Its center of gravity will move that little tiny, 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 tiny bit of distance. But that's exactly what does happen. The big thing does move. And if you have 2 things of equal size, then you'll see that they're both going to be moving the same speed.
An acceleration, but gravity's not a force, excuse me, but gravity as an acceleration, we actually have to define what that acceleration is.
Yes, and your definition of acceleration is some sort of, well, you find yourself a coaxial cable to travel down. Some kind of coaxial cable stuff is doing all of this stuff. So it's all kind of a string theory or something. A bunch of rubber bands are making it happen. You don't have any description.
The 2 principles, and one thing that Eric Dollard got right in all of his understanding of field theory, and I used to talk to him quite a bit on the phone. He's sick now. He doesn't have time to talk to anybody, but the one most important thing that he said is that you can't even understand electrical theory without understanding counter space.
Yes, counter space. So we need that word. They've already fucked space, but now we have to take something that's already been screwed and have some kind of counter. So instead of there being a concept of nothing and something, we'll have nothing and counter nothing. So we'll call all the somethings counter nothings. Well, that makes a lot of sense. Not.
Well, what about counter space? A field has a Cartesian footprint. When we talk about a toroidal divergent force vector,
no, that's really Cartesian. A toroidal force vector. Just again, so a minute ago there was no force. All of a sudden we have a force vector. So, okay, what's the force made out of? Jello? The toroidal, whatever, spinny current of Jello something? And again, how does that actually make something attract?
We're talking about something that has a Cartesian value over a period of time with a resultant effect. But gravity has no Cartesian footprint. There is no XY coordinate by which...
well, again, it's 3-dimensional, and of course it does. Gravity can be very precisely diagrammed. That's what Newton did. So, I don't know, what are you talking about? Of course it has an explicit... it doesn't disappear and do anything funny. It does things very within the rules of mechanics.
Which we could actually map if we refer to something, i.e. gravity, which is acceleration, but it is not even a field, nor is it a force, obviously so. But
okay, it's not a field, it's not a force. So again, how many times are you going to use these words and then reverse yourself? It just doesn't make any sense. It has to be one or the other. You can't get it from nowhere, so something has to convey the energy that makes something move. It can't be just come from nowhere. So it has to come from the jello, or it has to come from stuff moving through the jello, or stuff not moving through the jello, or it has to come from something.
It is also not an autonomous field modality.
Okay, so it's nothing. It's absolutely nothing. It's the magical, just the way it is. The God thing. The angels do it. Some magical, make up your own little dwarfs that do it. Because he's not going to give you an explanation. And like I say, people suck this shit up. This fucking drivel that you can make no sense of it at all. Just silly words put on top of each other. And, you know, this is just so depressing.
So we have to make three absolute statements from the perspective of Platonic retroduction that gravity is not a force.
Okay, Platonic retroduction. So you can't just say logical. Let's be logical. Okay, it's not a force. Let me write that down. NF. No force. Okay. It's not a field modality.
Gravity has no Cartesian locus.
Okay, well, I don't know what that means, so I'm out of luck. Okay, so no Cartesian locus. I don't even know what that means. The things that are being moved by it do, so I don't know what you're talking about. I don't know how you know the thing that you're not describing doesn't have some substance to it, but whatever you're saying, I don't know what it is. What does that mean? It doesn't have any Cartesian locus.
And thirdly, I think about 1,000 things at once. I'll get back to it.
Oh, right.
Gravity has a zero locus from which all else accelerates.
It has a zero locus, so now he's going to use locus a lot, I guess, and all else accelerates. Fine, yes, we understand that's how gravity works, is it causes acceleration. Point is what's causing the acceleration. I would argue it's because a force is being absorbed. Yes. One of those ones we can't see, like the photons. We actually can't see the ones going all the other ways. We can't. We can only see the ones that crash into our eyeball. So we don't really see the energy, you know, unless we have an eyeball that can receive it. So we don't have any eyeball that can receive gravity. So if you didn't have your eyes, you'd really be out of luck. Light wouldn't mean too much to you. You'd be just, what the fuck? What's all this talk about this force? I don't see no force. But yeah, it could still be there, right? You seeing it isn't really the definition of existing. You can measure it, like doing this. You can kind of measure, you can kind of see, if you visualize it, you could actually imagine, oh yeah, there's a bunch more stuff coming through this way than coming up this way, so it goes this way, because the Earth is blocking a whole bunch of shit. Yeah, that makes sense.
So if gravity has no Cartesian footprint, and it's certainly not a force.
Okay, so he knows that for certain, that it's not certainly not made of something. So there's no element to it. There's no materiality or quantizableness to it. When I think, you know, like I said, rationally, I don't think he could say that, because clearly we can do that. We can kind of quantize it. We can have very tiny little bits of discrete bits of gravity caused.
And it's certainly not an autonomous field modality. We only understand gravity through our limited human intellectual comprehension of...
No, we understand it through all the things we've watched being affected by it, and very small things, and, you know, and yeah, it's actually a nuclear force. It's actually moving the stuff inside the atoms. But each little atom gets pushed along. But again, this guy doesn't believe in atoms, apparently. He doesn't believe that there's little places where a different kind of nothing exists. Well, so yeah, there's a something and there's nothing. I don't know why this is complicated for people. See, there's stuff, and then there's the stuff around it, which is nothing. See, there's nothing, and then there's stuff bits. And the real question is the stuff bit could be as big as the Earth, and we sort of figured out that you can break the Earth into lots of pieces, and you can get down to some pretty small little stuff bits, little electrons and protons. Now they're going to say there's little Higgs bits and quarks and all this other crap. Yeah, maybe that stuff you could let go of. But there are bits, and they get pushed about, and we know they get pushed about by these little photons. So we know the little photons are about as small as you get. You can't really find anything in the universe smaller than a photon. Can't do it.
What we experience, and we would reify water is one thing, like a child, and steam is another, and ice is another thing. And we know all of these things are one and one thing only, and that would be water.
Well, that's not really how we relate to them, though. So again, frankly, I mean, they're a completely different configuration, and they'll be in, it's like saying, well, we know the diamonds are carbon. Well, it's a little hard to see it that way. It's a little hard to see a lump of coal or soot coming off a candle as the same thing as a diamond.
Specifically, there's only one field modality in the universe, and that would be magnetic. Yeah.
Okay, so all we have, the only field modality, even though there was no fields, now we have a field, is magnetism. Now, I would kind of agree with that, actually. But it's not a field of magnetism. It's a property, and that's the property of charge. And yes, that exists. There's polarization in the universe. There's stuff with two different polarizations. And when you filter those polarizations in specific ways, you create phenomena like magnetism. See my website for details. Blah, blah, blah.
Other field modality would be a hybrid, which would be electromagnetic, but electromagnetism by definition is a coaxial circuit. Electricity is phi times psi equals Q in Planck of electrification.
Okay, so now that was, so that all his little sycophants, they just suck that up. That to them, psi times phi by blah 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 blah. That all meant something to you fuckwits. I mean, just amazing. Yeah, electricity is just a byproduct thing. It's the movement of electrons. It's not a real force. The force moves the electrons, and the force moving the electrons is the little bits, the quanta. And they're pushed around by the polarization of the magnet.
Meaning specific that electricity is a hybrid between dielectricity and that of magnetism.
So now we have the unspaced stuff, whatever that was called, I forget. And now we have dielectricity, which is a word they do use in physics, but it's just kind of silly. I mean, it really just has to do with insulators versus conductors, and it's not a very useful term.
Even electricity is merely a hybrid reification of the coaxial circuit.
Okay, a reification of a coaxial circuit. Now, how the hell he's going to get this coaxial circuit into magnetism? I mean, it has photons traveling this coaxial circuit, which somehow means they're going this way, and then somehow they go back to where they were. That's what a coaxial cable does. The positive current goes one way, and the negative current goes through the outside shell. That makes sense to these people.
We have transverse, whether it's circular linear polarization, transverse electrical and magnetic, and longitudinal pulse perturbation.
Okay, so the cable's sending stuff forward and it's sending stuff back, but it perturbates in a direction. So somehow in the process of sending stuff forward and sending stuff back, it somehow sends more stuff forward because it keeps going forward. Something like that.
I.e. the dielectric. This would be rarefactions and compressions in the ether.
So, rarefactions and compressions. That means relaxations and compressions. So, you didn't need to use the word rarefactions. So, that just means after you compress it, it relaxes back to its steady state. Yeah.
Therefore, electricity is also not an autonomous field modality.
Yes, it's not an autonomous field modality. It's some other kind of field modality. Rontonomous.
And if we eliminate out gravity, which of course is not a field modality, and we...
Right, okay, so gravity is not a field modality, but magnetism is, and it's coaxial. Okay.
We understand what electricity certainly is, and this is quantifiable. Planck's constant, phi times psi equals Q in Planck of electrification.
Psi times phi equals Q, that sounds something to do with Planck's constant? I don't think so.
Electricity is magnetism and dielectricity.
Okay, so electricity is magnetism and dielectricity. So if you add dielectricity and magnetism, you get electricity. Which, again, electricity is just known for basically counting how much energy it takes to move electrons. And that's all it really is. It's an amount of force it takes to move a certain number of electrons a certain distance. That's electricity.
Then we are only left with one thing. The only field modality that has a Cartesian coordinate exists either as itself or as a hybrid. That would be magnetism and electricity.
Okay, well, whatever. I didn't understand any of that, but this is a hybrid, blah, 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 magnetism. Okay, it's all about magnetism.
Electricity is existent as a hybrid with dielectricity and magnetism. So we're a large...
So he said the same thing three different ways. Okay.
Large mass has magnetic coherency, for example, or incommensurability. Acceleration overthrows in the case of... Now we know for a fact, when we refer to black holes, we know that these...
Oh, dear. So, I just wish you'd do gravity and just do it so I understand it. You know.
Entities exist, but black holes certainly a misnomer. They're certainly not black, and they're certainly not holes. But
okay, they're not black, but are they concentrations of matter? I mean, so I don't know. If they're not black, they just use the word black to point out that they're not on fire. You do understand that, right? I mean, they're not producing visible electromagnetic energy, so we can't see them because they're not producing any light.
What if we can imagine and stretch your imagination, and it requires no stretch of imagination, it's actually hyperlogical.
Hyperlogical. So all this stuff is hyperlogical. Coaxial cables of magnetism pulling the Earth to the sun is hyperlogical.
Where you actually have the case where a supermassive, we know as the stars burn out, the one thing that they're left trying to burn is iron. And here we have a ferrous object that undergoes coherency. And once we have coherency set up, which cannot be set up in either hydrogen or helium or any of the elements leading up to iron, we know that these supermassive entities, once they reach a state of supermassive iron, they undergo coherency. Coherency is not additive, it is multiplicative.
Well, we also know that none of that happens in extreme heat. There is no magnetism. Magnetism's lost. Heat is repulsive to the process of creating the atomic structure necessary for magnetism, the order. Magnetism is an order. It's an order of, it's a filter, essentially. It's making something complicated. And the complicated thing can't exist in extreme heat. So burning iron will not get you magnetism. The opposite will happen. Cooling it will.
What does that mean specifically? Well, do you know the difference between a 5-watt light bulb and a 5-watt laser? A 5-watt laser is multiplicatively more potent than a...
Completely made up. There's no multiplicatively more anything, okay? They're LEDs now. You take an LED light bulb that's, burning, say that one's probably 20 watts, 15 watts maybe, of energy. And it's spreading it out over a whole wide surface. Laser beams spreading the energy over a very small surface. There's no more light. It's just being distributed differently. Shit. But there's not more.
5-watt light bulb.
You don't understand what a watt is. A watt is a measurement of energy. energy. You have to release it as something. So if you want to say that laser beams don't get as hot as white LED, all colors, go ahead and make the argument, but I don't think you can make that argument. So if there's no waste in heat, it's 5 watts is 5 watts. It's the same amount of light, same amount of photons.
Both have the same input, so what is the attributional difference between a 5-watt light bulb and a 5-watt laser? Do you know the difference? A 5-watt light bulb is absolutely useless even to read a book by, but a 5-watt light...
Well, see, that's... yeah, I know you piss away money all over the place, so, because you're, infinitely wealthy and all that crap, but, no, these new LEDs, 5 watts will get you a lot of light. A lot of light.
Laser will scorch out the back of your retinas and will burn a hole right through your damn skin.
Yeah, and so will the light bulb if you can take all of its energy and focus it into a beam. We just can't laze white light.
Both of these are 5 watts, so what is the attributional nature of a laser, for example? Light amplification by stimulated emission of radiation, right? Well, that's a description, that's not an explanation. Do we know what incommensurability and coherency is? Most people don't even know what the word incommensurability is, but what about coherency?
Yes, well, I don't think you're being very coherent at all. You're not fulfilling any obligation to explain anything with this drivel.
You think you know what coherency is? Well, it refers to coherent light. But that's merely a description. Again, what is it in explanation that actually defines coherency such that it is multiplicative? The only thing that defines a magnet before it becomes a magnet...
It's probably not even a good subject, just in the sense that this idea of any absolute coherency is probably not attainable when it comes to light. Anyway.
Is merely an attribute. The neodymium iron boron lump, in the case of like a supermagnet, before it is magnetized, the only differentiation is not quantitative. It is exactly identical in quantitative value before it becomes a magnet and after it becomes. So what gives it...
Well, see, that's where you just don't get it. Yeah, it's not the same in the sense that, first, again, the process of making something magnetic means you have to disrupt its shape and form and structure so you can reform its shape and structure. So if you thought of it as a bunch of triangles inside the matter, the triangles can be in all kinds of shapes and pointing in all kinds of directions. And what happens with magnetism is you line up all the triangles perfectly so they, aren't wasting any space, or wasting less space, let's say. They have a very ordered relationship to each other, and that's what makes them into a filter. That means that they can have a pointy side and a flat side facing some portion of the universe. And that's how they get a north and a south. So they become a filter.
The denotation of a magnet after it's been magnetized. Once we have polarity, we have incommensurability, we have coherency. Before that it is...
Yeah, so you could say that. You could just say something like that. Yes, magnets have to be ordered. They have to be structured. They have to be put in a state of... commensurability and all that kind of crap words just are useless. I'm not coming up with great ones myself, beyond the fact that there's a structure and an order, and that's what you're after. You could put this in real words. You don't have to use this preposterous language.
Just a lump of ceramic, neodymium iron boron slug. Once it, before it becomes the magnet, once it actually becomes the magnet, we actually have field coherency, where if we have two of these objects in close proximity, they'll actually smash your finger and break your finger.
Yes, but see, they're not doing it. The thing you don't think exists is the force is actually doing that. And I just give for the brief explanation. The force it's basically just a simple idea. There's pressure always around everything. Because the universe, like background radiation, the universe is always creating and producing a bunch of these little bits flying in random directions in all directions. And what gravity is, or magnetism is, and all this stuff is just the absorption of that force by certain percentages and rules. And those are Maxwell's equations. And they have to do with protons and electrons inside of this stuff. But the point is, it's like if you just thought this arrow is a bit of momentum. When the photon goes in, if it doesn't come out right away, okay, if it stays in there, and it releases some other arrow going another direction as a replacement, and it just keeps this one, then it has an imbalance in a direction, it moves in that direction. So that's what's happening with gravity, is any portion of some momentum that has any element in the direction of the two things will be absorbed. And when you absorb these arrows, then they can't hit the other object. And so all the arrows you absorb in the direction of the thing will mean the thing didn't get hit by those arrows, it got shadowed, and it means it will absorb more arrows going this way than this way, because there's less coming this way. So it's certain, it has a certain probability of absorption, and because there's more arrows available on this side than this side, it'll absorb more of these. That means it'll move this way, and as it moves this way, that means it absorbs some arrows going this way, which they didn't hit over here, and that means this will move towards it. So it's induced acceleration because there's a force making it happen. A force. And the same thing happens with magnetism, in the sense that the force is polarized. It's in two varieties, red and black, you could say. And the red will come out one end and the blacks will come out the other end. And that's it. Really simple.
So what, if there's no difference in the quantitative nature between these two entities, then what is it of the attribution or qualitative nature that defines what we call the magnet?
Again, so he's not getting to anything, no description of why magnets attract or why they repel. Nothing explaining it, nothing mechanical that's causing the process. You know, what I would explain that two magnets, you know, with their polarization the same way, north side with this black side here, there's little pieces of stuff going back and forth here that keeps reflecting, because it's the same polarization, and it can't go through things of the same polarization, so it just goes back and reflects. The same's happening with the other side. The bits that are the same just keep reflecting, and so as you bring the magnets closer and closer together, it's like, just imagine a ping pong ball bouncing, and if I make the space it can bounce in narrower and narrower, means it has more bounces, it hits more stuff. It actually ends up with more energy, in the sense of it hits more things. And its energy is really just how many times you impact something.
Gravity is merely incoherent dielectric acceleration.
Yeah, again, so incoherent dielectric acceleration. So now we have this concept of dielectric acceleration. It doesn't have a material form. He didn't say that Jello does something. There's nothing. There's no explanation of what that is. What is dielectric acceleration? What causes it? Draw me a picture of something being dielectrically accelerated.
Have incommensurability nor coherency set up in, say, any mass, the moon, the earth, or any other large object, or any mass in general.
Again, nothing, no mechanism. There's no mechanism. There's no mechanism. It's supposed to be a discussion about physics, and there's no physical mechanism.
Organic matter, all of these things have magnetic fields. We have toroidal magnetic divergences, which actually set up in molecular constructs.
Okay, well, this whole idea of magnetic fields, again, would have to be the strength of the filter. And yes, every atom has a bit of magnetism because it has two things. It has the plus proton and the minus electron. And we could think of the electron as being black and the electron as being red. And the force is black and red. And, you know, by logic you can say the black stuff on black stuff reflects, and you can say black stuff hitting red stuff goes through, and so there you have two different reactions, and because of those two different reactions you can filter the force.
Both biological and non-biological, but what gives definition to the magnet? What gives definition to the entity, for example, on the larger scale we call...
Right, and you're not doing any of that. You're not defining anything or describing anything or modeling anything or anything.
A black hole. We have a supermassive entity, and this is where you're going to have to wrap your mind around something that's hyperlogical, but which you've never thought of before.
Okay, it's hyperlogical. Again, who uses words like that? And how can you possibly use it? Hyperlogical is, you know, don't throw puppies in front of steamrollers. I mean, what are you talking about? What is hyperlogical about this crap?
For something that has enormous mass but has no magnitude.
Okay, it's right. So he did that one. I mean, I've heard that one before. Right. So this magnitude thing, and somehow magnitude isn't related somehow to mass. When we know that mass has to do with why nuclear bombs are so effective, is because of converting mass into the energy that it really is. It really is a bunch of energy inside the atoms. Oy.
This would be the case for acceleration in this supermass, which actually has field coherency, overthrows the divergent force vectors, which give depth.
Okay, so the field coherency overthrows the divergent field vectors. So there's two fields, the divergent field and the coherent field. And they're in battle with each other, and the mass is stuck in between the rubber band people and the spring people.
Definition to the magnitude of the volume itself. So can you imagine something that's incredibly massive? Here we have the case of a super large entity of a dying or dead star.
Which is not the definition of a black hole, by the way. It's kind of silly to think about a dying or dead star which has lost some portion of its mass becoming a black hole, or being a black hole in any sense of the term. It's less massive, not more massive.
Who's burned everything up other than iron, and which has set up field coherency. Now it is like a supergiant magnet. Now it's mutual acceleration.
Well, it doesn't really burn stuff up in the in the sense that it's converting hydrogen into helium. So I think it would have some helium left over, but whatever.
At a zero null vector at the center of which is so high that we actually have a mass. We have something that's supermassive but has absolutely no magnitude.
Okay, there we go. Supermassive but no magnitude. Again, meaning absolutely nothing. It's already kind of known that gravity, to have the magnitude of gravity, doesn't require you to burn anything or use anything. Just like a magnet doesn't age or lose its potency all by itself. You have to whack it out of it or heat it out of it. But if you left it alone, it would keep producing magnetism, because the magnetism isn't coming from it. It's coming from the outside. The magnet's just a filter for an external force. Oh, people are so fucking stupid.
That's like saying something is super huge, yet it is so accelerative that its acceleration vector is...
Okay, so that has something to do with acceleration, and there's no evidence that they accelerate anywhere or do any of this stuff. It could just be sitting there as a dying star. It's not accelerating. It's not doing anything.
So strong that it overthrows its ability to maintain a magnitudinal footprint in a Cartesian universe.
Okay, a magnitudinal footprint. And again, so this was in the context of something being created like a black hole, when really he's talking about something turning into nothing. A magnitudinal footprint. How is it losing its footprint? How does this make any sense at all? If I cut the Earth in half and throw away half of its magnitude, does it somehow lose its velocity? No. Does the other half of the stuff's over? Is there anything different about that half? No. It has all the same properties. It's just smaller.
Of volume and magnitude. That is no stretch of the imagination. It is hyperlogical, it is platonic, and
it's platonic and hyperlogical. And who cares about this platonic again? It matches with dumbasses who didn't even know what an outhouse was, who could only dream about an outhouse to take a poo in. They can only dream about running water.
Is retroductive. This would be the case of the black.
Retroductive, so that has something to do with some sort of deducting process where you put two facts together. Instead of deducing the third fact, you retroduce it. I don't know.
Cool. What do we understand about multiplicative values and
multiplicative values? What do you understand about them? Multiplicative values. What are multiplicative values of valuations of valuizing and the valuati? It's just a matrix of complex valuation.
coherency? Well, you need to wrap your mind around something as simple as a 5-watt light bulb, which is useless to anybody.
Again, you got to get up with the times. 5 watts of LED light is a pretty good flashlight, actually.
I don't think you could buy a 5-watt light bulb versus a 5-watt laser, which is insanely dangerous.
So he doesn't even think you can buy a 5-watt light bulb. Yeah, you can. I got a ton of these. This is just an old crappy LED, the old style. But you can get the new ones now, and there's 5 watts coming out of one of these little LEDs, and you can't really look at them. If you look at them with your straight on with your eyes, it'll leave an imprint there and shit. It's very bright.
They happen to have a couple.
Like I said, this bulb here, it's not 5. I think it's like 7 watts. 7 watts. It's like a 40-watt bulb or a 50-watt bulb. Yeah, it might even be a 60. 7 watts.
Love them. So what's the difference? They're both 5 watts. They have the exact same input. 5 watts of power.
Right, it's the same number of photons. I know that's hard for you to believe that, I guess you don't get the concept that when the light bulb shines the light in all directions, okay, that there's not as much to go around. I guess you don't, maybe I can put it into a frosting analogy on a cake. Maybe you can understand it that way. Yeah, if I spread the frosting around the whole cake, okay, then the frosting's thin. But if I line the frosting all up in just one line across the top of the cake, I can make a big giant lump of frosting. Yeah, maybe you can understand it that way. Same amount of frosting. You're just shaping it different.
What is a known entity of power?
So all these idiots, 266 likes. I mean, the comment section is just full of, "Oh, Ken, I just love you. I want to do some retroductive posterior hyperburloiding."
What's the difference? One's a multiplicative. It's not additive. It's a multiplicative.
So now we got another term, a multiplicative. It's not additive. It's multi-powerful. So again, his theory is he's actually proposing this as a fact that a 5-watt LED shaped this way, and one in the form of a laser diode, that is one that sends the light a little bit more straight, in a beam. It has to use a lens to do that. It needs a lot of help to create a laser. But anyway, that somehow there's more photons being created by one than the other. He thinks that.
The incoherent nature of another. Incoherent light versus coherent light.
And he thinks there's a multiplicative effect. Because you took if I take this outside and I focus the sunlight into a little beam, he thinks I'm multiplicating the photons. I'm not doing any such thing. I'm just pointing them all, forcing them all to go one place when they were heading for other places. I create a shadow when I do it. See, that's the funny thing, right? When I do it, I actually create a shadow. See the shadow over here? I create a shadow. There's a price to pay for the light you stole.
But do you really understand what that incommensurability or that coherency actually is? A field has a Cartesian footprint, but the only field that has a Cartesian footprint is either magnetism or a magnetism hybrid. That would be electromagnetism.
Right, so there's magnetism in the hybrid, which is magnetism plus dielectricity. Plus electricity. something like that. Times 5 divided by di.
Or electricity, which is magnetism and dielectricity. Gravity has only a zero locus.
Ah, back to the locus again. It's a zero location. Okay, maybe. No center? I don't know. Locus is center? Whatever.
Gravity has no Cartesian footprint.
Again, so it's not a something, it's a nothing, but the nothings are all different kinds of something in the nothing verse, the Jello land. So Jello land has lots of little characters in it that do lots of silly things, and they make all the stuff in not Jello land, like material things like batteries, do things. They're all being run by the people in Jello land.
At the center of any supermass, there is obviously no gravity. You can take the largest mass in the universe.
So the center of even the smallest mass, there's no gravity. That's right, because you're in between two equal amounts of stuff. And when you're in between two equal amounts of something, there can't be anything, the shadows are even. You're getting just as little light from this side as you are from that side. You're going to block just as much. So whenever you're between two things and there's the same amount of stuff on one side of you as there is the other side of you, there will be nothing affecting you.
Center of which obviously it would free float if you could go to the center of it, correct? So where is the center of gravity? Gravity has no center.
Well, obviously the center of gravity is a concept of recognizing that you can't possibly get from the outside to the inside without going through all of the imbalances first. So see, if you go 1 foot down, then you only have 1 foot here, and you have 4,000 feet this way or something, whatever, 4 million feet. And as you go 2 feet or 5 feet, it's always in balance until you get to the center. So yes, you're always in balance, and once you go past the center, then the imbalance goes the other way. But yes, so the idea of the center of gravity is the point where that's exactly what they're pointing out the center of gravity is. The center is the point where you have balance. It's the center. That's why it's in the centers. The center is when there's equal amounts on all sides. It's sort of the definition of it.
It is the inverse of all Cartesian vectors. Thence with, logically so, and retroductively so.
Yes, well, and it's also a fact that the amount of gravity you're getting affected by will diminish as you head for this center. There's not more gravity. If I dig a hole into the earth, there isn't more gravity down there. There's not more gravity down here. There's not more gravity down here. Now, there's more pressure because the pressure is through the gravity is pushing on this surface up here, and that pressure wants to crush you. But there's no gravitational pressure. It gets less and less gravity the deeper you go. You get more and more weightless as you head for the center.
It is illogical to say anything other than gravity is an acceleration towards counter space.
Okay, so now we're back to counter space. All right. Well, anyway, we're going to run out of time. Counter space.